Hello, everyone. It's my pleasure to welcome everyone to this very first seminar, CIVICA seminar of the month of May. Before we start, I want to give everyone a very, very brief run-through of how this seminar is going to run. So I'm going to give a very brief introduction of the run-through of the seminar. So I'll give an introduction to our speaker, and we'll have roughly 45 minutes of talk, and then we'll have questions at the very end of the seminar. And for those of you who know how these seminars go, these seminars are about tackling complex societal challenges through novel methodological and data-driven approaches, and they're hosted by several institutions such as Hertie, EUI, the Central European University, Bocconi, Sciences Po, and obviously your host today, which is the London School of Economics, and particularly the Data Science Institute within it. And it is my great pleasure and an honor to introduce our speaker today, Dr. Marie Oldfield. And I don't even know how to start her introduction. Marie is a senior lecturer here at LSE at the Department of Mathematics and the CEO of her very own consultancy, Oldfield Consultancy. She's an expert in AI and ethics with a background in mathematics and philosophy. She's an executive board member at the Institute of Science and Technology, where she founded the Artificial Intelligence Group and the Women in Tech Group. She's an advisor to several stakeholders, such as the UK government, the Ministry of Defence, and the legal sector, among others. Her work focuses on ethical AI, and she recently was invited to speak at Chatham House on AI and ethics. She's the creator of the new global professional accreditation in AI provided by the Institute of Science and Technology, and she's going to tell us all about this particular accreditation. So without further ado, the floor is yours, Mary.
Thanks very much. It's a pleasure to be here. I will just share my slides with everyone. There we go. Hope that is working. So yeah, it's nice to be here. Thanks for having me. So I'm going to talk today on AI standards and frameworks by the Institute of Science and Technology. You can find me on ResearchGate, LinkedIn, X, Google Scholar, all those good places. Let's begin. So this is based on academic research. I'm diving straight in here. So we based all this on academic research from empirical research that's been done by Holstein et al. And by me. I surveyed over 100 different sized businesses. Holstein et al. Surveyed over 267 on how they generate and design models and algorithms. And there were numerous takeaways, huge lists of takeaways. Some of them were there's a lack of guidance on regulation and legislation for people building models and algorithms. There's a gap in education and professional development. There's a lack of best practice, and people are unsure where to turn for guidance. So even in these studies, people were saying this, and the thought was, well, is there no professional body? Is there no single source of truth? And when we looked around for that, there wasn't, which was quite concerning, because professionals generally have a professional body to turn to, such as the Royal Statistical Society, the Institute of Maths and its applications, and here we didn't. So all the practitioners, most of them in the survey, wanted to do better. They needed this guidance, and there seemed to be a gap. We got some really good statistics from this research. a lot of it was around PR and showing the public that people were being taken seriously in terms of fairness, that the algorithms and models were being developed in a fair way. Businesses didn't want to be seen as unfair because it would affect their customer base. People did not want to be legislated against, so they didn't want law cases, court cases coming from badly implemented algorithms. Although we have seen court cases on algorithms recently, there was an overwhelming number of people that didn't want a potential PR disaster. So this was kind of one of the key motivations in trying to make sure that they appeared fair, they looked like they were doing the right things, and they were being ethical. But again, a lot of people had a sense of ethical responsibility, and 95% of all respondents in my study wanted to improve. So this study was done across platforms, and the problem was there is a diversity issue within AI, and the platforms that we were putting this survey across, overwhelmingly the respondents were middle-aged white male, British, or similar. So we were struggling to get a really representative sample. So what we did notice again is that women were not well represented, and in doing a further empirical survey and empirical research into why women thought that they weren't valued as much in this area, produced a whole new paper that I presented last week at the International Conference for Gender Research, where women in tech are having huge issues in terms of being able to communicate, being able to challenge, being promoted, being taken seriously, being supported in any caring responsibilities. That wasn't there. So that research really backed up what we saw in this study, that women were not really getting to be heard within the AI discipline, and that kind of cascaded down into diversity. We didn't have a diverse response. So even though these statistics are what they are biased in a way. So you've got to bear that in mind when looking at these. But I do think, and I'm encouraged by the fact that 95% of all respondents wanted to improve. So that is encouraging. There we go. So when we dug down into the root causes of what the problems actually were, and you can check out my analytical modelling paper on the UK government about this as well, it was the same kind of issues. Communication tools. Well, instead of having better communication, the developers and the people involved in the survey wanted tools to be able to communicate. So they felt they weren't able to communicate with modelling teams very well. The default of we've got an issue with some sort of perceived bias or some sort of fairness issue, we've got to collect more training data. Sometimes it's about looking at the quality of that data, and so there's a whole statistical methodology lacking in the way that these respondents were building their models, where they were trying to use really basic ways of fixing the models, where actually what they needed to do was get a statistician to help them look at the quality of their data and use it more efficiently. Nearly 60%, 57.9% of respondents wanted to avoid a potential PR disaster. I mean, of course, we want to sell our products. We don't want reputational damage. We don't want risk. We want to mitigate financial and reputational risk. So this, again, was a huge concern for respondents. And it's not something that is unique to this study. The issues found in this study were the ones that were found in my analytical modelling paper, and they stretch back over 30 years. So there is a historic issue with doing modelling correctly and using algorithms correctly, and we're still experiencing the same issues that we were 5 years ago, 6 years ago, 20 years ago, because they're not being improved. Because a lot of the issues around this are human-centered issues, such as leadership challenge, communication, resource management. They're not the issues that you would think. You might think, well, it's technical issues that are causing the problems within algorithms and implementation. It's the human part of it that is the driver, according to the research that's been done. So when I looked at this research, I was thinking, well, we need a professional body, and we need to bring together professionals in this industry, and we need to be able to have a voice, we need to be able to network. And so the concept of a professional body for AI came about so that we could network and share knowledge and expertise. One of the main parts of it was advocating for AI, because practitioners are in every industry and every discipline. They're not just in STEM, they're not just in computer science. They can be working on rock art with native populations. They can be in health, they can be in finance. So we need to be able to bring these people together and advocate to different bodies and government about what do we need, because the worst thing that can happen is people that aren't really sure about AI go ahead and legislate and regulate, and then you know, professionals could potentially get put in jail or they could get fined when they didn't know that they were meant to be doing this. They didn't have a voice in creating this policy, but potentially they didn't have the education to be able to adhere to any policy either, which I will come on to shortly. So professional bodies play a really big role in regulating and supporting professional standards and ethics. And that was one of the key things that I found was missing in the AI space, as well as being able to develop and advance people's careers. Because at the minute, there's a proliferation of AI courses everywhere. There's no real regulation of that by the UK education system. So you could do any course and be taught anything, and nobody would be able to tell whether you've been taught the correct stuff or had been assessed correctly on it, or if an industrial course or a commercial course was worth the money. So we felt that we needed to do something around that as well. So what we came up with, in addition to the standards and frameworks that I'll come on to, is degree validation. So the Institute of Science and Technology gives quality marks, and you can see the quality mark that we use here, to modules and courses in higher education and industry, to show that that is a course that is going to give you the right type of information and assessment for you to be able to go out there and be an ethical developer or an ethical contributor to the design and development of AI. This is really critical as a development because the QAA, the body for regulation of teaching and assessment in the UK, doesn't have ethics in higher education or secondary education benchmark statements. The benchmark statements are used to prescribe what kinds of things you should teach, and the assessment for that. We don't have that yet. We don't have a benchmark statement for AI, so we don't have anything kind of directing us, helping us, guiding us, telling us what to do. We're putting modules and courses out there that we think hit the mark, but are not consistent across the educational industry. So this is one way in which we can ensure that professionals in AI are getting the education they need, and that they're not paying for courses that are substandard or aren't going to teach them what they need to know, or might even teach them something incorrect. This is our standards and framework for AI professionals. We spent a long time developing this. It's been years in the making. We sat down with industry, academia, numerous professional bodies, and we said, what do we need to be able to do for AI professionals to be able to do their work ethically, to be able to develop, understand all the different guidance, regulation, legislation out there, and know that if a practitioner goes in to build a model or an algorithm, they can do it robustly, they can do it ethically, and they can do it safely. So our standards are split into these different sections, 5 different sections, and the letters you see at the bottom are the letters that the practitioners get after their name once they've been assessed. There's different levels, so we split it into RTech AI, which is entry level, and that applies to students. At the minute, we are running training courses, which mean that if you take that training course, you automatically get RTech AI at the end of it if you complete the application form to the correct standard, because you get taught what you need to know to come into that level. Students are admitted to the IST for free, so you get into the Institute of Science and Technology, and then you can go for your RTech AI as a student. And as you're moving up in middle management or mid-career, you can get RPI, which is Registered Practitioner of Artificial Intelligence, and advanced leaders and visionaries can go for Advanced Practitioner in Artificial Intelligence. We will be looking at converting that into a formal chartership in the future. It is a long process to do that, so we are working on it. But these are the 3 levels that you can come in at. We've been accrediting people across the board in these for the past few months. So we've got people out there now that are accredited with our professional accreditation to be able to model responsibly. We chose these 5 sections because we think that you need to be able to gain, process, understand and apply knowledge within your discipline. You need to be able to understand problems and apply the correct tools in an ethical and robust way. We needed a full section on ethical responsibility because that is just so hard just to shoehorn into any other category. Accountability and understanding the impacts on society and the processes it takes to do that are quite wide-reaching. Within the diagram that I'll show you shortly, when you look at the pipeline for development, it is critical that ethical responsibility is embedded in every single part of that. So we pulled that out and said that needs to be a key feature of these standards and framework. Interpersonal skills and communication is critical because that is something that is hampering a lot of technical development right now. Just being able to talk to non-technical people and being able to communicate across interdisciplinary teams. So that's something that we really need to be able to improve on constantly. So that is one of our pillars. Critical evaluation. We wanted to know that people could reflect on what they were doing, apply their knowledge appropriately, but also say, well, did that work? Could I do something better next time? Is there another way of doing this? When I've finished my model, can I look at validation and verification before I implement it? Can I look at testing? Am I following the correct processes? In addition, we wanted to make sure that people knew how to handle data and also collect data, and that they could be critical about how they did that so that they could do it efficiently. And again, this comes down to having the right professionals in the room, because it might not be that you've got a degree in statistics, so you might need a chartered statistician to come in and help you do the data part, but just being able to reflect on, what does this data tell me? What is in this data? Could this data be biased? Am I missing anybody out of this data? Have I encompassed diversity within this data? Have I got what I require? Saves you a lot of time because, well, and money and reputation, because when you get halfway down the pipeline to building your model, you're not then going back and saying, oh, hang on, we've missed all these people that we should have had in there and all these data points. So now the model needs to pause because we need to go back and collect a load more data. So it's about critically reflecting on each stage and making sure that you're confident that you've done what you can to be ethical and robust within that process. All of these sections are broken down in the handbook into smaller segments so that you can really break down what's in the 5 pillars here if you're going to apply for this, and also to understand how to follow the process. Professional standards is something that is crucial for anybody in any profession, because we need to exercise integrity and have professional conduct standards. Especially as a chartered scientist and a chartered statistician, I have to do that. I can end up going to court or putting in court reports as a legal expert, so I need to be able to show that I'm following relevant codes of conduct, but also keeping up with my professional development, so that I'm not doing a talk and missing out half of the current research in the area. I need to be able to have a good awareness of my discipline at all times. And then that reflects into my work, because I can take on board that development and say, right, let's try something new. Let's use this process and we'll see how that works. And so we can test things out and have a concept of continuous improvement. AI practitioners are not always technical. People think that AI is just a lot of coders sat in a room sometimes, and it isn't. It's a lot of people. It takes teams of people to put these algorithms together, and subject matter experts aren't always technical. I can end up working with military, government, health, all kinds of different disciplines that are not technical at all. But if I don't take into account their subject matter expertise, then I've already failed as a modeler or a practitioner, because I can't build that model correctly. I don't know what their in-depth subject matter expertise is and what their knowledge is about their area, but I can help them model it when they give me the insights as to how their data works and how their research works, so that I can then go ahead and start putting that into a pipeline. However, there is no space within this, there is no point within this pipeline where I'm developing something where I then say, right, we don't need the subject matter experts anymore. The team that I have at the beginning stays with me all the way through when I develop these things, because I need them there. I need to know, is the data correct? Are we handling the data in the correct way? I've got an issue with this data. It looks like there's a problem. What is the issue? Can we go in and fix it? The project manager has to manage the project. We need to be on budget. We need the subject matter experts in there because they might pick up something that's incorrect. I've seen a model fail through one line of code being an incorrect translation of a human assumption into computer code. And it took weeks of digging through the model code to try and find that to fix it. So it's important to try and get everything as right as you can up front, but make sure that you're involving the correct experts at every stage. Especially when you get, I mean, models are complicated these days, and I use the terms model, algorithm, AI interchangeably, because when you code these things up, you get to a point where it becomes software, which then involves things like unit testing, software testing, code bases, recorded code, commented code, implementation, user testing. There's all kinds of things, because we're looking now at not just statistical models and mathematical models. We're looking at cross-disciplinary work. As a statistician, you're not trained in computer code testing. You're not trained in unit testing and user testing necessarily. A computer scientist that is trained in that might not necessarily be trained in data collection and analysis. So you need more and more people as time goes on to make these things work. And a model, it can be all kinds of things. It's generally something that has data, and then something happens with the data to maybe simulate, predict, analyze, and then there's results at the end. So the models that I've worked on have mostly always been of that kind of framework. There are all kinds of different models. I mean, neural networks, LLMs, all these kinds of things, they're all data-driven analysis tools. So it's anything like that that you're working on. And it always starts with a question. Can we, predict, can we look at Native American rock art and figure out what the meaning was behind these different pictures? Or can we examine this art and find anything that might be culturally significant from the way that people behaved back then? Or it might be as easy as, I need to put these ships in certain places in the world, operational research techniques. How do I do that? I want to predict the stock market. I need to figure out new health interventions, but I've got all this data and I don't know what to do with it. How can I get insights from that? So it normally starts with a question and ends in some sort of insight, and there's data within that model framework. What it isn't is Skynet and robots and people sat there in a back room like Mr. Robot coding all day long. It's not, it shouldn't be like that. If that's what's happening, then there's something gone a little bit wrong. Subject matter experts bring a huge amount of information to a model. They are the people that know exactly what is happening within that ecosystem. So if you've got people working in health, they'll know what the survey was that was done. If there was a survey done, they'll know how people reacted to it, what the behavior was around it, what the questions meant. If the meaning was, it could have been slightly different to the written question, but did everybody in the room understand what the meaning was behind the question? If we do X, Y, and Z, what do we think the answer might be based on the subject matter expert's experience? So they're really key people to have in the room when we're developing. They also need to be able to understand the model and how it works, not necessarily down to the nth detail of, mathematical equations, but they need to understand how it works, because there might be a point at which they say, well, actually, that wouldn't be correct in real life. So we need to decide, is that something that we want to assess and analyze, or is that something that we need to remove? So it's important to have people there that understand the real life part of it when you're trying to either simulate or predict or do something else. There's lots of challenges for AI practitioners at the minute. understanding the landscape. It's shifting every day. I mean, we're getting new tools all the time. We've got to understand the risks with new tools. We might want to know how to use the new tools. So you never stop learning, you never stop developing, but that pace is faster than it's ever been before. We need to understand how AI is used, because it's used on us, it's used by us, it's used for us. Decisions are made on different things. The visa algorithm in the Home Office was an algorithm that was used for visas, and that got pulled out because the algorithm didn't work correctly, but the issues had not been spotted at the beginning where they should have been spotted. Everybody needs to be aware of risk, and this is something that is not really taught well across the entire education system. So being aware of risk inherent in using this technology, but also building this technology. It's one example of this is when we teach tools. What tools should we teach? What supports what it is that we want to teach? What are the risks within using that tool? And it is really difficult to get to the bottom sometimes of these commercial tools. How were they built? What is the transparency? What are the risks? What do I need to be aware of? What do my students need to be aware of? And if they build models with these tools or they use them, how do they communicate the risks and awareness or write it down for other people? And those kind of caveats and assumptions around the technology that we build are really important for the public to be able to understand, and for us to be able to be transparent. And if we've got non-technical people in the team, we should already be being transparent, because we need everybody to understand what it is that we're doing when we're building models. And that comes on to everybody being involved in a conversation. We all need to be involved in the conversation now, because it affects us all, every single one of us. Even if we're not building, we are still using Alexas, we're using Siris, we are using ChatGPT. There's lots and lots of tools that we're using. We've got the issue of plagiarism at the minute. How can you tell if somebody's plagiarized? And the problem with that discussion is it starts at the point of what tool can I use to figure out if somebody's plagiarized. Whereas what we need to do is go right back to the beginning and say, what does education look like? Because if you draft an essay with ChatGPT, is that any different from getting a mentor to help you get a structure together? If you edit your essay with AI, is that any different from getting a proofreader? Where does the help stop and the plagiarism begin? And that is a really difficult conceptual issue. And it's not the case that we need to go and find a tool that tells you how much of this has come from ChatGPT in your essay. We need to decide as educators what it looks like in terms of what are we teaching, where does your effort come into this? What, you can't just take away things like spell check and drafting mechanisms because we're scared of plagiarism. We've got to some extent embrace the technology, but use it to benefit ourselves, not to cause undue reputational damage by running down the plagiarism route, which is particularly difficult to run down anyway, since there are tools that can apparently tell you if there is plagiarism, but they're not transparent, so people don't know how they work. It's a very big thing to accuse people of this, and it's not something that we should be doing without having a really in-depth conceptual discussion about what it is we want to achieve by doing it, and where we kind of stop saying, well, that's your work and it's something else's. If you uploaded your paper to ChatGPT, then one of these tools might say that you plagiarized it when actually it was just there in the database at the time. So it's a really sticky area, and it's one that we need to just go take a few steps back on and figure out how we want to address it. And that comes on to being able to challenge. If we can't challenge these tools, and we can't challenge how they're built, and we can't communicate well enough to challenge, and we haven't got the right people on the teams, then what are we actually doing? We're blindly making technology and AI and models and simulations and whatever we're making that are going to impact society. And if it's a real life question and the answer's related to real life, there is potentially going to be an impact downstream that is on people and society. And the whole point is to keep them safe and make sure what we're doing is robust and ethical, so that we're not causing any damage. We've seen benefits decisions made, and people have committed suicide over these decisions, and they weren't necessarily correct. So before we go out there and we start using technology and implementing technology, we need to be really careful, because it can cost people lives. I mean, I did used to do military work, and that definitely, you want to bring everybody back safe, but having an impact on society, everybody should be safe. There is no way in which we should be, implementing things and then impacting people at that level in our society. So we need to be extremely careful how we work within this new technology. There's a lot of communication gaps. I've seen that in the conferences that I've been to. We've got a lot of words that we use. There are really big discussions around words like bias, around what is AI, what is generative AI, all these kinds of things, and even things like trust and fairness. What do these words actually mean? Which is where we need to go back to language and start to specify what we mean in terms of shared definitions. Sprite Plus has been doing a bit of work on that recently in terms of cataloging definitions of words that we can all work with. And this is just really important as well when we're speaking to the public and non-technical people, because everybody needs to be able to understand in clear language what it is that is happening, so that they can assess the risk for themselves and form their own opinions and challenge as necessary. So we need to reduce the language barriers. They are in a technically complex area, but that is no excuse for not reducing the language barriers. There are use cases across, I mean, this is just 4 industries. There are just about every industry now is using some form of AI, and people are using this to make decisions about people, which ultimately impacts their lives and their families' lives and society as a whole. It's not a small thing to speak about the future of humanity and how AI will impact that. AI can influence the way that we behave as humans, and it does do that through mechanisms such as anthropomorphism, dehumanization, targeted advertising, decisions that are made about us. This kind of thing does really impact human behavior. And if it makes people less sociable and it isolates people, then it creates more vulnerable people. We've already got a lot of vulnerable people out there. We don't need to create more by making bad decisions with technology. It's not a case that we should be saying, can we do this? We might be able to do it, but should we do it? And if we do it, what are the impacts? And we need to really consider that within not only our research, but our design and engineering of these systems, to make sure that they are as safe as they can be before they go out there. As I was saying, systems and algorithms and processes, all of these different words are all kind of representative of the same thing, how they're perceived in industry. Recruitment, your CV's scanned, keywords are pulled out. It could be that they're using AI during an interview. There's services that we interact with, government services that use AI chatbots, that kind of thing. Banking uses a lot of prediction and modeling. So you can be impacted by this. And it's interesting because a lot of these models and systems and processes have been around for a long, long time. But it's only really now that people are kind of saying, hang on, I'm being impacted by high profile decisions that are being made by government. What else am I being impacted by? And as we're starting to notice things like social media platforms sharing data, targeted advertising, it's becoming ever more obvious. But we need to consider that for every obvious thing that we see, there might be numerous other aspects that are affecting us on a fundamental human level that we're not necessarily fully aware of, and that can have impacts on us as humans and society as well. Especially anthropomorphism. Robots are, in the most part, made to look like us because it gives the opportunity for us to create an inappropriate emotional attachment to them because they look like us. So we start to give them goals and dreams and personalities. which is great until you realize that you've got this attachment to something that may or may not have your best interests at heart, may or may not be manipulating you. I mean, if one of these robots was living with you and it was doing your housework or whatever, but it was giving you targeted advertising or taking your behavioral data or something like that, and then personalizing itself to you, is that a good thing or a bad thing? How close do you want to be to a robot? Would you rather have a human do the same thing? I mean, I'd rather speak to a human than a Tesco till. I'd rather speak to a human than a chatbot. And I find that it's a lot easier and humans understand me, whereas chatbots and till systems definitely don't understand me. They can't even change what they're doing to try and adapt to what I need them to do. But chatbots do try and adapt in certain ways, but still they're not really sometimes understanding the message that I'm trying to get across, the meaning I'm trying to convey, whereas a human might pick that up through shared experience. So it's a really deep philosophical, psychological, sociological discussion, and it's one that really needs to have more attention brought to it. And I think philosophers, sociologists, and psychologists really need a higher profile in this, because moving forward, we are really going to affect ourselves with this technology. And I think we need to figure out as a society, what do we want to be? How do we want to exist? Do we want implanted brain chips and genetic engineering to make us all the best at certain things? Or do we want to be human with all the risks and mess that brings with it? And that's a decision that we've got to make as a society. And it's actually quite interesting, because at the minute, policy is being developed based on this. So these are really big questions that we need to think about, how we want to function as we move along. This is the modeling pipeline that I was telling you about, and these are all the steps that we've broken out. And this appeared in a published paper of mine, and it was contrasted against a statistical model or a mathematical model, the way that we used to build them. And the outcome is that it used to be 4 or 5 steps, and now it is quite substantial. And what I've found in my research and in my industry experience is that the first 4 steps are generally missed. So the conceptual part, in terms of understanding what you need to model, what data you need, how to collect it, how you're going to process that data, what the model will look like, how it will function, what is the transparency within this. It normally starts at step 5, which is extremely concerning. And this is why when you get round to step 10, it can fail. It can be a really big chance of failure. And I've seen really large, expensive models fail and had to be taken offline because they were not functioning correctly. And it costs a huge amount of money to go back and start again and fix them. I've seen models that, because they were coded in certain ways, you couldn't actually fix them. You had to start again. So it's really important that at the beginning, we're really clear on motivation, question, why we're doing it. Do we need to do it? If we do it, what does this mean? What might the impacts be? All that kind of discussion. And then the transparency around what will we do and how will we do it. Collecting data and creating the model is a real crucial part. This is the kind of bedrock on which you build all the other steps. You can do as much testing as you want and identify issues, but if originally your data is not good enough, you can waste a huge amount of time having to go back and then do more research on study groups, focus groups, collecting open source data, and then you still might not have the correct data, because all you're doing there is addressing one particular problem, not conceptually understanding what it is that you need in terms of data to actually build a model in the first place. As I was saying before, there's testing steps in there now. And users need to be brought in very early, because they will tell you what their lived experience is. We can't avoid or exclude lived experience within this, especially when we're talking about people and the way people operate and society as a whole. That's how you end up with things like, I mean, the example that I always use, and I can't understand how this happened, but apparently a hand wash dispenser was invented, but it didn't work on anything other than white hands. So the data set there was clearly, biased towards white people's hands. I mean, this is just a really basic consideration at the beginning. Who might be using this hand wash dispenser? It could be anybody. What happens if it's somebody that hasn't got hands, but they want to use the dispenser because they want to clean themselves? Well, you need to consider that as well. You've got to consider all the different ways in which people might want to interact with and use a hand wash dispenser. People with small hands, children, are they catered for, or is it just people with big hands? Is it man-sized hands or other size hands considered? So these seem really, really stupid little pieces of detail, but actually they're critical to designing things that work for the people that will be using them at the other end. Validation and verification in step 8 is a process that the government put in place in their Aqua book a few years ago, and it tells you how you can make sure that your model is working correctly in the way in which you not only expect it to, but technically in the way that it's expected to. So there should be results come out that you can look at as a subject matter expert and say, this is kind of what I would expect based on my experience. But then there's another part that says technically, the way that the model is working, is that correct? So you've got software testing in there that will do part of that, but then you really need to get the paperwork together for validation and verification purposes to make sure that not only you're ready for any audit that might come along, but that you've got the transparency. Every single step within this process just encourages and gives you the tools to be able to be transparent in your entire process. I have businesses come to me and ask me to do talks and then say, what tools can I use to make my model transparent? Well, you've made that model and you've designed it and you've built it, so you should really know what's in there. So it should be transparent. You shouldn't need another tool that you can't necessarily trust, and that tool is maybe not transparent, to then make your own tool transparent. So it's important to follow all the different steps and make sure that this is done correctly. Audit can sometimes be a real tick box exercise, and you might get 2 pages of an answer for one point on it, or you might get 10 pages. Audit is notoriously gameable, where you can tick boxes by writing certain things, but it might not be that you've done it in the spirit in which it was intended within the design process. So audit is something that it's a really good gateway, but it's not necessarily embedding ethics and robust design and development within this process. So that's where I felt we had a huge gap again. And I've seen models go through audit that were unfit for purpose as well. So it shows that actually maybe it's not sufficient to have an audit process at the end. And ethics boards as well. I've not really seen a purpose why you create this whole thing and then you go to an ethics board and say, is this correct? Or you get an ethics board to come in and kind of give you advice. You need a process in the beginning to be able to adhere to, so that you can get advice on dealing with each section, which is what the people with the accredited logos at the bottom of this slide can do, because they have proven that they can model ethically and robustly and safely. And then we've got the implementation testing. So we might have user issues, we might have testing issues, we might have interoperability issues, we might have technical issues. All of these things are going to need fixing. So it's not just a one and done. You need to implement in a test environment, test it, implement in the real world and test it, and then fix anything that might come up. There'll be incremental testing. I've never seen a model be implemented and it work correctly. And if it does, I'd be really skeptical and saying, is it really working correctly, or is there something in there that looks correct, but maybe it's not doing what it's supposed to do? So there's a lot more steps these days in the way that we design and engineer AI. And this slide is to illustrate that everybody should be involved at the beginning. It is not a case that people start getting involved at step 6, step 7, step 10. We need people involved at the beginning so they know what they're doing, they can see what's happening, they can get their timeline straight. If there's something that can't be achieved, then they can tell you about it. If there are different ways to do it, you can discuss it. And the diversity and discussion and challenge within that team should really inform how you move forward in an improved way. So we've got a lot of potential upcoming regulation and legislation. I'm going to have to hurry up a little bit, I think. And we've got existing court cases that are going on. So it's really important to be aware of all of this type of stuff that's going on in the background, because eventually it will become critical and necessary to understand it, not only in terms of our profession, but in terms of managers having to implement processes to make sure that systems are modelled robustly and ethically, but that anybody having a new system imposed upon them can also understand it as well, because we don't want people to be accountable and liable if they're not fully trained in understanding what it is that they're accountable and liable for. So we've got to plug that gap there. So you can see from this that we've got lots of challenges that we're working on at the minute in order to improve the way that we design, engineer, and implement AI systems. So we've got these accreditation standards and frameworks. We did this not in a vacuum, but with industry, academia, and government. We had a steering board. We approved this. We've got people that are already accredited. And some of the good things that people have said is that they gain recognition for their achievements. They're recognized for being able to work in this way, but also they can interact with like-minded professionals and learn from them too. So it's a networking opportunity, as well as demonstrate their competence and skills, because it's nice to have that certificate and be able to say, look, I can do this, and not have to not have that formalization within the discipline. Some people have said it makes them feel more confident, and also what it does do is it means employers can set up job descriptions more accurately, and people that are going for those jobs know what they're going to be doing, and they know how to do it, and they can say that they can do that. That was a huge gap that we found as well within our empirical research. The demonstration of professional development and the certification of that was slightly missing. Earning potential, opportunities for employment, all of that increases with professional accreditation. And it's important to reduce risk and liabilities, both for employers and employees, and have a pipeline for ongoing professional development of staff. And really crucial, have a voice in policy, education, hiring, legislation. Have a group of people that are in that discipline that can say to professional bodies and government and the EU and all kinds of different agencies that we need X, we want Y, we want to develop Z. We can have that voice as a community now, and we can be aware of new developments and have a voice in those too. So how does the IST facilitate this? We've got the AI group that is involved in a huge amount of work in terms of funded educational projects. We work with governments on government projects. We're doing a lot with women in tech in terms of diversity in AI. So we've got a lot of funded projects going on, but also the seminars, webinars, we've got training courses, mentoring schemes, networking events, and conferences. There's a huge amount going on in the AI section of the Institute of Science and Technology. So check us out on the website, and remember that students can sign up free if they want to as well. So there we go. That's the end of my presentation. I'm happy to take any questions.
Thank you, Marie, for the very interesting presentation. Well, while I'm waiting for people to actually ask questions, and you can do that as I wrote, either on the chat by writing your question or by raising your virtual hand. So I'll start by asking you a couple of questions. So you started at the very end of your presentation talking about the benefits of the accreditation for well, the practitioners and for their employers. Could you maybe expand a little bit on that one, because it being the very end of the presentation, you rushed a little bit through that point.
So the job descriptions were getting quite crazy at one point in terms of hiring people in AI and data science. There were multiple coding platforms needed. People should have 15-20 years experience. Some of the jobs you couldn't actually do because I'm not sure how you would learn that much stuff. And ultimately, the employer was employing people, didn't understand what they would do with them, didn't understand what their work was, didn't understand how they would operate. and the employee was coming in thinking, oh, I know what I can do X, Y, and Z, but then the communication wasn't happening. So even though the employee could do amazing things, the employer didn't know what they could do, so they couldn't even speak to each other either. So there were problems with that within industry, and we've seen that again in the empirical research. So having this kind of framework means that there's a communication method, there are terms that you can use, there's ways of expressing what you need and what you do and how you do it, so that you're not really getting into that trap all the time of trying to explain technical concepts to people that are not necessarily technical. And as well, with increased reputational and financial risk, it's critical that both employers and employees are aware of not only the area, the new work that's coming out of the discipline, but they're aware of maybe things that they're not that good in certain areas, things that they excel in, so they can share their best practice, but also build up and do training on areas that they're not as good in. So it's just a really good way to be able to formalize a discipline, and especially within industry as well. And I think that's a good way of, where the Royal Statistical Society does it, it means that we're able to use that as a kind of conduit, so that we all know what we're doing, rather than, oh, we need a statistician, but we're not sure what you might do. Can you help us with X, Y, and Z? You can kind of read the website, go through the papers, have a look at the resources, then talk to one of us and find out a bit more without feeling completely overwhelmed.
A bit of a follow-up question on this. I mean, the problems with AI are not exactly new. I mean, there's been a lot of debate about the issues of AI, and there's been a lot of work going on about ethical AI. It's not for the past 5, 6, 7 years already. So why do you think it's taken so long for people to start talking about an AI accreditation, and to even start mentioning an AI accreditation body at all?
Because it's really hard to do it. Because it's taken us years.
Why is that?
So I think that a lot, there's so many. I mean, if you look at my papers, there are lots and lots and lots of problems. So it's really difficult to kind of zoom in on one and say, what can we do about this one? And then you get overwhelmed and say, what can we do about the next one? So when you start talking about how you formalize a discipline, that's a huge conceptual and practical undertaking. And that's taken us a long time to get to this point where we've got this. And so, many people talk about this stuff, and also the definition of ethics is not well understood. If you're a philosopher, it might be different from a computer scientist. So again, you've got to create some sort of understanding of the language between yourselves. And to get the people in the room, I mean, my group that work with me to establish these standards and framework is interdisciplinary: geographers, philosophers, computer scientists. We've got military in there. We've got a really wide, diverse group, because otherwise we couldn't have put these standards together in the way that we did. And without working with industry, academia, and government, we may well have been completely off the mark in what we were developing. So it has not been an easy undertaking. And I think, yeah, we should have been talking about AI accreditation sooner, but I think somebody expected most people probably expected an existing body to take that up, or maybe the Turing to take that up. But it's not always the case that, the Turing might not be involved in professional accreditation because they've got research interests. The Royal Statistical Society is about statistics. It's not necessarily all about AI. So we had the gap within the Institute of Science and Technology, where we could say, we are science and technology, and we're also AI, so we can move forward with AI because we work within the science discipline, and AI is a big part of that. So in that respect, I think it just needed a body to kind of have that space to do it, but also step up and actually get it done.
So where do you anticipate the coming obstacles for the AI accreditation to be?
I think we'll come across improvements, definitely. I mean, this is our first iteration that we've put out there, and we've got people accredited. So what we've got is a community on Slack where we all talk about what's happening. And where we've got people out there in the field, we're expecting them to come back to us and say, right, we need to maybe tweak this. We might want to look at doing this. We need to improve this. So it's not something that's just done and that's the end of it. This is something that should be organic to the profession and the discipline, and it should develop in line with that as well.
Oh, I saw Martin putting on his video, so I thought he might want to ask a question, or am I wrong there? Okay.
Sorry, no, I didn't want to ask a question. I was just trying to accidentally
Okay.
Anyway, it's a very nice talk. Thank you very much.
Thanks.
Okay. Then I might ask a follow-up question with the remaining few minutes. You talked about the gaps that we have in the current education system relating to AI. So could you maybe elaborate on that? Where do you think we could maybe try and improve things?
I've been talking to the QAA for a while, and I've sent them papers because we've done some, well, I've done some research again on the pedagogical approach to AI in the UK specifically. And there's a fairly large gap in terms of we teach people how to do certain things and we teach them to pass exams, but we don't necessarily teach the concepts behind it. And I used to teach secondary maths, so what we didn't have was the time to be able to get the understanding from the pupils. We just had to get them through the exams sometimes. And especially when you've got a class of 34, you can't just spend a huge amount of time on, you know, exploring the concepts. So where the subject benchmark statement sits at the minute, I think we've got the math statistics and operational research one, which is still one. And in my opinion, I think it needs to be split because these are they're not completely separate disciplines, but they've got their own challenges. And AI is one of those. It's a separate discipline that needs to be expanded upon. Where we're taught how to teach, what to teach, how to assess, all that kind of thing, we're given guidance on it. That's what these statements should do. So I was really concerned that in the last couple of years when these statements are updated, they weren't really examined in that much depth, and they were kept more or less the same. So there's no mention of ethics in secondary and tertiary benchmark statements. There's no mention of things like caveats, assumptions, real life impact. There's, you know, this is how you model, there might be some sort of impact, but it's just not done in any depth. And we can see that there are so many issues in this discipline. We can see that we need to move forwards, and we're not educating people correctly because there's very big lack of understanding. So how do we adjust those statements to make sure that we've got statements for the disciplines that we need, but also the correct content in there to be able to make sure that the workforce of the future has what it needs? If you've got people coming through secondary school and university and they're not getting taught enough about critical awareness and risk and AI as users, how will they be able to be aware of this technology in the future? Our kids could be in any situation in the future with this, but they need the tools to be able to interpret that and choose how they act. Currently, that's not anything that's within the formal education system. And at university, the impact is even greater because the modelers of the future, the people that will be developing this tech and will be affecting society with it, are there now. And they need to be able to know this stuff, because otherwise, if they've not got ethics, they've not got robust modeling practices, and they've not got the kind of things that we've been talking about, we're going to end up in the same problems moving forward in terms of poorly developed technology, poor impacts on society, societal breakdown, societal alienation and isolation, inappropriate emotional attachments. All of this damages people, and you can't just change it back. There are generations of people that can be affected and impacted by this. And so we really, really need to make sure that we're teaching people the correct things. And I think those benchmark statements need to be changed to reflect that.
Could I ask a quick follow-up on that, if I may? I'm very interested in the educational impacts because you're quite right. We need to be instilling all sorts of skills in our students for the future world of work. But actually, ironically, the fact that generative AI exists means that we're being very conservative, even more so in our assessment methods. We're going back to closed book written exams that can't be cheated on. So it's sort of contradictory. On the one hand, we're going back and doing the old-fashioned stuff, and students being students will always focus their learning on what the assessment is ultimately, because they've got to pass the exam. So there's a real problem here. We need to find a way to allow students to use generative AI as a proper research tool, and yet be able to assess them fairly and confidently, knowing that they haven't done a misconduct of some form or other. It's a really difficult area, but we seem to be going almost backwards in terms of the way we're assessing students, because we don't trust them,
Yeah. And I think that that's a panic response, because it's easy to say, let's just put this easy fix in. It's harder to say, let's go back and understand what the concept is here, how we want students to learn, what we want to teach them. I mean, if a student goes away and just, has somebody write their essay from them, they might do that. If they do it with ChatGPT, what's the difference? I mean, we've got to look at societal values as well. Do you want ChatGPT to produce all your social media, or do you want it to be an expression of yourself? So it's all about coming back to that human part of it. What do we want to achieve, and how do we want to achieve it? And just going back to closed book exams is just not a way forward. It's just a way back. And at some point, we've got to stop avoiding that discussion and start talking about pedagogy and moving forward in a constructive way.
Absolutely.
And on this very interesting note, thank you, Martin. I'm afraid I'm going to have to close the session because we're run slightly over time. And thank you, Marie, again for a very, very interesting talk. Just before we close the session, I need to announce the next session, which is going to be in 2 weeks. And it's going to be a talk by Duilio Balsamo, and it's going to be hosted by Bocconi. So many, many thanks to all of you for joining today, and see you again maybe in 2 weeks.